Hello everyone, I'm Yuju Jung. Today we're going to look at a vector question about three planes in 3D space. Let's go step by step. So if you look at the question, the three planes are given in Cartesian form. And A asks, show that the three planes do not intersect. If all three planes meet at intersect, then it must meet at a single point. Then the system should have one consistent solution. So let's try eliminating variables and see what happens. So first, I will combine pi1 and pi2 to eliminate y. So pi1 So to eliminate y, I'll multiply by 2 in pi1. pi1 times 2. 잠깐만. 이거 적응이 안 되는데요? 잠시만. 다시. First, I'll combine pi1 and pi2 to eliminate y. So I multiply 2 in pi1, which I get 4x minus 2y plus 2z equal to 8. And pi2 is x minus 2y plus 3z equal to 5. If we subtract, we get 3x minus z equal to 3. Then I'll do a similar elimination using pi1 and pi3. And pi1 times 3 gives us 6x minus 3y plus 3z equal to 12. And pi3 is negative 9x plus 3y minus 2z equal to 32. If we add these two together, you get negative 3x plus z equal to 44. So we get two new equations. If you look at it, at 3x minus z equal to 3, and the other one is 3x minus z equal to negative 44. These can't both be true, so the system is inconsistent. That means that the three planes do not meet at one point. Okay, let's start part B. Verify that the point P lies both pi1 and pi2. For the first part of B, checking whether point P lies on planes pi1 and pi2, let's just plug their points in. So the Cartesian form of the plane is just given, and then we can just plug in the 1, negative 2, 0 into this x, y, z. So for pi1, we get 2 times 1 minus negative 2 plus 0, which is equal to 2 plus 2, which is 4. That works. And for pi2, 1 minus 2 times negative 2 plus 3 times 0, which is equal to 1 plus 4 equal to 5. That works too. So that point lie both planes. And second part, find the vector equation L, the line intersection pi1 and pi2. So that means if there is a pi1 and okay. For the second part of B, find the vector equation L, the line intersection pi 1 and pi 2. If you draw pi 1, something like that, and pi 2 is lying like that. There is an intersection line. That is L. We have to find out. To find out line equation of L, if we express plane equation L1 as, we can express it L r times 2 negative 1 1 equal 4, and pi 2 is r dot 1 negative 2 3 equal to 5, and let's just do it. Pi 3 is r dot negative 9 3 negative 2 equal 32. And these vectors are normal vector of plane 1. That one is normal vector of plane 2. So that let's call it N1 and let's call it N2. If we draw it here, if that's pi 1 and that's pi 2, we get this would be N1 and that will be N2. If we cross these both the vectors, we get another perpendicular vector here, N. And then this N vector N will be the parallel to the intersection line of pi 1 and pi 2. So we get the direction vector of L by crossing N1 and N2. So N1 cross N2, we can find out ijk 2 negative 1 1 1 negative 2 3, which is I minus 3 plus 2 minus j 6 minus 1 plus k negative 4 plus 1, which is negative I minus 5j minus 3k. So you can write line equation L r equal to position vector, which is pi p is, we have shown that p lies both pi 1 and pi 2, so p will be somewhere like here, 1 negative 2 0. So line equation of L will be r equal to 1 negative 2 0 plus t 1 5 3, the vector, the direction vector of the line L. And part C, find the distance between L and pi 3. So before we move the slide, if you look at these normal vectors here, these all three normal vectors are different. Means we've shown that pi 1 and pi 2 intersect like that, then pi 3 will be intersect like that. So 3 planes didn't meet at a single point, but they intersect in pairs. So if this is pi 1, and if that's pi 2, and that's pi 3, what we just found out L was here line. And in part C, they asked the distance between line and planes. Third plane, that must be the distance, will be shortest distance. There must be something like the distance between these and these. So start C with drawing pi 3. This is pi 3, and that's L, which just given in part B. And the point P is lie on L, which is 1, negative 2, and 0. And we want the distance between L and pi. And let's call it that's Q. So if we find the line, if we find line equation, let's call it N1, L1. And if we find the line equation L1, and then we can find Q, then we can find lengths between P and Q. Let's just first find out the line equation of L1. And pi 3 is r dot negative 9, 3, negative 2 equal to 32. And since negative 9, 3, 2, that's the normal vector of the plane, that means the direction vector of L1. We know that the P lies on L1 as well. Then L1 will be r equal to 1, negative 2, 0 plus s negative 9, 3, negative 2. Then Q will be something like x, y, z equal to 1 minus 9s, negative 2 plus 3s, and negative 2s. If we plug it back to Cartesian form of the plane equation, we get 9 minus 9 times 1 minus 9s plus 3 negative 2 plus 3s minus 2 times negative 2s equal to 32. If we simplify it, then s equal to, we get half. Then if we plug half into that equation, we get x, y, z equal to negative 7 over 2 and minus half and minus 1. Then that's Q. Then we know P is 1, negative 2, 0, and Q is negative 7 over 2 and negative half and negative 1. So PQ will be square root of negative 7 over 2 minus 1 square plus negative half minus plus 2 square plus negative 1 minus 0 square. Simplify it, we get root 94 over 2. So that's the shortest distance between L and pi 3. That's the whole problem. Thanks for watching. I hope the explanation was clear. And see you next time. Thank you.